Assalamualaikum and hi to Dr. AIZUDDIN and others. So we are from Group 1 and today we are going to present single stage compressor. Our group members are Anisha Zrina, Muhammad Akil, Ahmad Dinish and me myself Nurul Shafiza.
So I will explain about introduction for this experiment. Single stage compressor is a type of compressor which is gas or air is compressed using a single cylinder and a piston. In this experiment, single stage compressor is used to observe change in temperature being fed. So, what is the objective of the experiment? First, to observe on how heat is converted to work. Second, to evaluate how quickly a single stage compressor heats up. And lastly, to analyze the steady state heat loss of a single stage compressor.
So for scope, the first one is the single stage compressor convert the power into the kinetic energy by compressing air and pressurizing air. The second one, initial readings for related parameter will be recorded followed by the activation of motor. The third one, the data will be recorded at 1 minute intervals until the temperature have the same consecutive readings. The last one, the heat loss of the compressor in steady state is evaluated along the time interval.
Now I will explain about the theory. So what is actually compressor? Compressor is a device used to compressible fluid, either gas or vapor. But how? By reducing the fluid specific volume during passage of the fluid through compressor. Single stage air compressor working principle. All of the compression occurs at a single cylinder in a single stage reciprocating compressor. The cylinder is connected to two valves. It is an inlet or we call suction valve and outlet or we call delivery valve. The pressure differential affects how a spring or plate valve opens and closes. Cams control the function of mechanical valves for suction and discharge. Now we move on to working principle. In a standard single-stage vane compressor as shown in figure above, a fixed volume of air is trapped between two sliding vanes driven by an offset rotor. This volume of air is then pushed to the outlet where the area and hence volume is reduced. Therefore, its pressure becomes higher and it is squeezed out of the outlet port.
This is how the single stage compressor being set up. As you can see, we already label the component in the single stage compressor. We have compressor 1, red inlet valve, flow meter, red outlet valve, thermometer, barometer, compressor 2, tachometer, motor, rotary, vane compressor, spring balance and electric power. After we identify the position of all the components, we can carry out this experiment with the correct precise steps so that we can avoid unwanted events. So firstly, you need to switch on the power and then fully open the ring inlet valve by turning clockwise this way. And then record the initial readings for T0, T1, T2 and P0. Next, switch on the motor and start record T2 every 1 minute intervals using stopwatch. Then, set the compressor outlet pressure P2 to 1 bar gauge by turning the red outlet valve clockwise to increase the pressure. After turning the red outlet valve, you can adjust the spring balance to ensure the motor's indicator is positioned between the two block lines before reading any motor force values. Then, you can record the value of P1, P2, flow meter, motor spring balance and electric power. Next step is to use the tachometer to record the motor speed N. Then, continue record T2 until two similar readings. To stop the experiment, reduce the compressor outlet pressure P2 to 0 bar gauge using the red outlet valve by turning the valve anti-clockwise to decrease the pressure. Lastly, don't forget to switch off the motor and the power.
From the table of result, we can calculate the specific volume using formula V0 equal to RT0 over P0. So we must change the temperature from degree Celsius to Kelvin and for the pressure from bar to kilopascal. So after we substitute the value, we can get the final answer is 0.8259 meter cube per kilogram. Next, we can calculate the volumetric flow rate using the formula V equal to V in over 60 times 10 to the power of 3. So, the answer we can get from this calculation is 0.0043 meter cube per second. On the first table of result, we also can calculate the mass flow rate, which is the formula is M equal to V over V naught. And the answer we can get from the table is 0.0052 kilogram per second. Next, we can calculate the power out of motor using the formula Wm equal to motor speed times motor spring balance times length of torque arm times 2 pi and times gravity 9.81 over 60. Then we can get the answer, which is 589.215 watt. Next, from the second table, we can calculate the energy added into the system using the formula Hc equal to mCp delta T, which is Cp is specific heat capacity of air and delta T is T2 minus T1 from the second table. And the answer we can get from the calculation is 224.718 watt. And lastly, we can calculate the heat emitted using the formula Qc equal to Wm minus Hc, which is Wm that we calculate before, which is power out of motor minus Hc, which is energy added. And then we can get the answer is 364.497 watt.
Now, I will explain about the graph 1. Based on the graph 1, it shows that the temperature T2 of the compressor increased with the time. During the experiment, there are a lot of heat generated that will increase the temperature and pressure. Now, for the graph 2, it demonstrates that the energy increased as time advances. The compressor motor will compress the gas, which increases the gas pressure and temperature. According to the first law of thermodynamics, the work done on the gas increases energy, resulting in a rise in temperature and pressure. Now, for the last graph, which is graph 3, it shows a clear trend of decreasing heat emission over time. Initially, higher work might be needed to compress the gas, leading to higher heat losses. As time goes on, the system may approach thermal equilibrium where the amount of work required stabilizes, leading to reduced heat emission.
So for discussion, the first one, the energy that is being input to the system when the system is heat up. The first one, internal energy increase. It is because particles inside the compressor will move faster due to an increase in kinetic energy. Second one, temperature rise. When the kinetic energy increases, the temperature will rise as well. Third one, energy loss to the environment. As the temperature rises, it often loses some of the energy to the environment through mechanisms like conduction, convection, or radiation. This energy loss tend to increase as the temperature of the system become higher than that of its surrounding. So the last point for discussion, amount of energy lost as heat as compared to A, the work input to the compressor. The amount of energy lost as heat is lower compared to the work input to the compressor. B, the heat added to the air. The amount of energy lost is higher than the heat added to the air at the beginning of the experiment, but at minute 10, the amount of energy lost is lower than the heat added to the air until the end of the experiment, which is at minute of 22. Based on this comparison, the energy of heat added to the compressor increases with time as the process goes by.
Now, I will make a conclusion about this experiment. In this experiment, to to evaluate how quickly a single-stage compressor heats up and analyze the steady-state heat loss of a single-stage compressor. Throughout the experiment, it being found that the outlet temperature, which is T2, increased exponentially from 70 degrees Celsius until 130 degrees Celsius, where it remains constant after 20 minutes of heating. When T equals to 20 minutes, steady state occurred as the energy added by compressor and heat emitted from compressor remains at 224.718 watt and 364.497 watt respectively. The energy added to air by compressor, which is Hc, also increases while the heat emitted from compressor, which is Qc, decreases with time. If the compressor outlet pressure P2 is reduced from 1.0 bar to 0.5 bar, the temperature will decrease by half. The heating time could be longer and the shape of a graph will be less steep.
Some safety precautions must be taken in this experiment. Like firstly, the personal protective equipment PPE. We must wear appropriate PPE for experiment and wear a closed-toe shoe. Then, handle the apparatus carefully. This is to avoid breaking any apparatus and avoid missing any apparatus. Then, report any injury. Please report to lab assistant to get the first aid treatment. Then, don't switch off motor. Do not switch off motor when it's switched on. This is to avoid the breakdown. And lastly, don't forget to tidy up. Please clean the work area and return all the equipment to designated place. So we end our presentation. This is the list of references that we use to do some research for this experiment.